Hello everyone, I am Anala R. Gowda, an Electronic and Communication Engineering student studying in Sri Venkateshwara College of Engineering. Today I am going to give the presentation on Reflex Klystron Oscillator. So we will move on to the next slide. Topics to be discussed: construction and mechanism of Reflex Klystron Oscillator, working principle of Reflex Klystron Oscillator. So first we will discuss what do you mean by Reflex Klystron Oscillator. A reflex Klystron oscillator is a specialized low-power vacuum tube used to produce oscillations at microwave frequency. Klystrons are basically specialized tubes used as amplifiers and oscillators at microwave frequency range. Its principle of operation is velocity and current modulation. Then we will move to the constructions of the reflex Klystron oscillator. So here it gives the construction of the reflex Klystron oscillators. It consists of anode, cathode, heating element, cavity, RF output, grid gap, electron beam and repeller, and then voltage. Then we'll discuss some points on construction of reflex Klystron. Here, the structure consists of cathode and focusing anode that combinedly acts as an electron gun for the tube. The cathode emits the electron beam which is focused inside the tube by focusing anode. And also a positive potential is provided as input, which sets up an electric field intensity. While moving, the electron undergoes a velocity modulation and the repeller applies repulsive forces on them. This leads to the formation of bunch of electrons. Further, this bunching will lead to cause current modulation. A repeller plate that causes backward movement of the electron beam is present at the opposite end of the electron gun. The potential at the repeller is made extremely negative in order to permit repulsion of light charges. A repeller plate that causes backward movement of the electron beam is present at the opposite end of the electron gun. Here, the repulsion is necessary in order to build electrical oscillations as the output power must be fed to the input. And here the potential at the repeller is made extremely negative in order to permit repulsion like charges. Thus, repeller is used in the structure of the klystron. And now we will discuss about the working of reflex Klystron oscillator. As we already discussed, the fundamental principles of operation of a reflex Klystron is velocity and current modulation. So, initially when the electron beam is emitted by the electron gun, then the early electrons EE experience a very high potential. Due to this, a strong electric field gets generated inside the cavity gap, leading to cause movement of electron towards the repeller with a very high velocity. Due to high velocity, the electrons penetrate deeper into the region of the repeller and thus require greater time to repel back towards the catcher cavity. But when the externally applied potential is almost zero, then the electron moves with a uniform velocity with which it was emitted by the gun. So these electrons are generally known as reference electrons ER. So in this case, ER will not penetrate deeply into the repeller surface and gets repelled by the repeller in the lesser time than the early electron further. The electron that was emitted by the gun after the reference electron experiences a high negative potential at the cavity. So this electron is generally known as the late electron E1 and moves with a very low velocity inside the tube. So here the penetration level of the late electron into the repeller space is least, thus takes a minimal amount of the time to get repelled back. So what do you mean by transit time? Here the transit time is defined as the time taken by the electrons to return to the cavity gap after getting repelled by the repeller. So before that we will discuss about the velocity modulation. Here it is to be noted that due to deep penetration in the repeller region, EE will take more time than ER. While returning towards the catcher, this change in the velocity of moving electrons is known as velocity modulation. And due to this velocity modulation, all the electrons get bunched while returning towards the catcher cavity. So in this way, bunch of electrons reaches the catcher cavity. This bunching of electrons leads to cause current modulation inside the tube. Therefore, at the time of returning, the bunched electrons transfer the maximal of their energy to the catcher cavity, thereby leading to the cause oscillations inside the tube. So, transit time, for sustained oscillation to take place, transit time is the most important factors. So here the optimum time for leaving the gun is centered around the reference electron, which is considered at a 180-degree phase shift difference from the sinusoidal applied potential across the gap. So next we will discuss about the bunching process. Here the x-axis represents the time and y-axis shows the distance traveled by the electron inside the tube. As we already discussed that bunching takes place at the time of the return journey of electrons, thus it is represented in the figure through E, R and EI are approaching the repeller with different velocities. Yet, while returning all of them are bunched at a respective time. So there are some specifications. The specifications are the operating frequency range generally offered is 1 to 20 gigahertz. It delivers output power in the range of 10 milliwatt to 2.5 milliwatts. The tuning range of Klystron lies between 5 gigahertz at 2 watt to 30 gigahertz at 10 milliwatts. Theoretically, the efficiency is considered 22.78%, while practically the achieved efficiency is only 10 to 20%. So here are some of the applications of the reflex klystron oscillators. The reflex klystron oscillators are used in receivers, radar receivers, radio receivers, local oscillation receivers, and it also utilized as signal sources in microwave generators and pump oscillations of parametric amplifiers. Thank you for watching my video. Please subscribe, share, like. We'll meet you in the next video.